igneous forms and structure. Normally, जितने subsurface के magma generate हुए, it travels through the fracture. सरफेस को ऐसे हम चेष्टा करें, मतलब फ्रैक्चर थ्रू ट्रैवल करे, तो टाइम टू टाइम जितने सरफेस को राइज करिवो माने से कोन शैलो डेप्थ को अप्रोच करिवो, जते शैलो डेप्थ को अप्रोच करिवो ग्रेजुअली तार टेंपरेचर डिक्रीज करिवो एंड टाइम टू टाइम जब कोन सॉलिडिफाई, जते सॉलिडिफाई हेबे तो डिफरेंट फॉर्म में सॉलिडिफाई हेबे, दैट डिपेंड्स अपॉन द स्ट्रक्चर ऑफ द सबसरफेस रीजन. सबसरफेस रीजन में जो फ्रैक्चर अछि, जो जॉइंट्स अछि, ताकू फॉलो करिकि से माने कोन हेबे मोरा solidify है. So say अनुसार you'll get different type of forms. And जितने surface को आसिबे also they will solidify, करना surface को आसला परे expose हेबे बा temperature obviously decrease करिवो तो सेठी से माने solidify. तो जो पूरा सब surface region में होची जो हम पहले intrusive superficial part रे होची तब पहले extrusive. So intrusive form and extrusive form that defined on the basis of their location. तो जेहेतु एक्सट्रूसिव फॉर्म टा नॉर्मली डिपेंड करे कि मोर लावा टाइप ऊपर ता सहित कि को एरिया से फ्लो करूची ता पर डिपेंड करे तार फॉर्म ऑफ स्ट्रक्चर. मोस्टली दिस इज नॉट कि एक्सट्रूसिव्स आर नॉट कंट्रोल्ड बाय एनी स्ट्रक्चर पे, कि नॉर्मली स्लोप ऊपर डिपेंड करे, बट इंट्रूसिव टा दे ऑलवेज डिपेंड अपॉन द बेडिंग प्लेन सपोज कि फ्रैक्चर स्ट्रक्चर आ पर डिपेंड करे हां, जतरे कि से माने ट्रैवल करे. So what are the different intrusive forms? में general example लेने बाथोलिथ में वाला लोकोलिथ, लैकोलिथ, तो से माने से अनुसारे different shape size अनुसार define कराए जाते. But they are broadly divided into two types. Intrusives are broadly divided into two types on the basis of their relationship with the bedding plane. So on that basis, they are divided into two types. One is your concordant, another is your discordant. So concordant bodies are those igneous intrusive bodies which solidify parallel to the strike of the contour or strike of the bed. तो कौन सी बेड का स्ट्राइक को यदि पैरेलल करिके magma solidify होची, तो it is solidifies like this. This is your magma. So then this magma body, it is called as your concordant bodies. Whether this thing is tilted or it is vertical. So always remember, concordant means it is not always be parallel to the horizontal. It always parallel to the bedding plane. That means if you have a bedding plane like this and a magma that solidify parallel to the bed, still it is considered as concordant because it is parallel to the bedding plane. So always remember, concordant thing, it should be parallel to the bedding plane. It doesn't depend upon, okay, you cannot say whether it is horizontal or not. It may be horizontal, may not be, but it should follow the bedding plane. It should follow the strike of the bedding plane. That is your concordant. Similar thing, discordant, which will cross cut the contour, which will cross cut the bedding, which will be transverse to the bedding. So in any case, that also can be horizontal, can be vertical, can be inclined. So these are the examples. No, these are Laccolith, Lopoliths, Sills, Batholiths, salt domes. Then discordant we have dikes, stocks, batholith, volcanic necks. Then you will get your ring dike, cone sheet. All those are also considered as your discordant. Understood? Next comes to your laccolith. Start from dikes. So dikes are discordant bodies. They're like this. The composition of your basic or you will sometimes call dolomitic dikes. So dikes are discordant bodies. Dikes are gonna discordant bodies. It will include the pre-existing rock, and always dike is younger than the surrounding contour because it is an intrusive structure. All the intrusive things are always uh, younger than the surrounding contour. So So the presence of dye can be represented, or presence of dye can be recognized by its margin. By its margin, they always represent a chilled margin. Always represent a chilled margin. Chilled means which have a different mineral orientation here. These are dikes. See, this is a chilled margin. Very shallow, intrusive volcanic rock texture characterized by glacier fine grained zone. Suppose this rock you can see here, these are coarse grain. You can see this. But at this margin, you will get different orientation of grain, or you will find a volcanic type of texture or glassy type of texture. That is a characteristic of your dike deposition, dike intrusion. So this is because these are very cooler rock. So suddenly they will sudden in contact with the magma, they will produce a volcanic or glassy texture. Understood? Also, dikes act on walls, like walls act as a barrier of flow of groundwater, which will sometimes may result good or bad potential of groundwater. Sometimes if it will block the flow of water, then water will retain there. It will produce a kind of good reservoir. Sometimes it will not allow the water to reach to the reservoir. So it might be a it might be good for groundwater or may not. Dikes are also important for the economic deposition. So these are the different characteristics of a dike. Then as it is it is in contact with the country rock, so it will produce reaction rings. So it will produce a ring-like structure. Any intrusive body, when in contact with the suitable rock, which is reactive, then because of incomplete reaction, they can produce reaction ring. So it is also a type of you can say texture, or you can also type of microstructure. So it is a ring-like structure. The zone of reaction produced which are found in the boundary of minerals, of grains or dikes, or you can say any intrusive body. It is like if suppose there is a olivine, you can take the example like this. We have olivine and the magma. So when it will in contact with the surrounding material which is silica, it will react. It will produce acerite. But if this reaction is incomplete, then so a ring will form around the olivine. So that is your reaction ring. So there are two types of reaction ring. One is corona, one is caliphatic bud. Corona produces the primary magmatic reaction, and caliphatic bud produced by secondary reaction process. So that you can say metamorphism. So after the deposition of the rock. So it can be considered as a structure. You also will also study it in texture of igneous. Corona structure or caliphatic structure? Corona, the ring is of two types. This reaction ring or ring, it is of two types. One is your corona. That means you suppose there is a rock which formed from the very magma and reacted with that magma. And if there is a rock which is derived from other magma chamber and it react with another magma, then it will be a secondary condition where the magma is reacting with a rock which is formed from another magma. That's why it is formed during metamorphism. When it comes to cone sheet also these are igneous intrusive structure which produce this cone shape intrusion, which is converged to a common point. There are several causes for the formation of which you can say cone sheet. One is where magmatic pressure is greater than lithostatic pressure. So if magmatic pressure is greater than lithostatic pressure, then it will break the overlying country rock and will intrude like a cone and also has a circular outcrop. It also produces in a you can say collapse caldera or cone region. You'll find cone seat. So particularly it is because where magmatic pressure is greater than lithostatic pressure. Where magma is emerging to the surface at a greater pressure. Understood? Then comes to batholith. So batholith, these are you can say larger igneous intrusive body. So if any igneous intrusive body measure more than 100 square kilometer, that we consider as a batholith. So mostly batholiths are granitic to granulated composition, or you can say felsic. So mostly these are felsic and intermediate rock types, such as you can say you will find granite, coal monzonite, diorite, granodiorite, all these type of composition you will find in batholith. So mostly batholith are from soft surface bodies, but after erosion they can expose to the surface. The superficial exposure part is called as a stock. After erosion, the part of the batholith that is exposed to the surface, it is called as a stock. Stock is a very irregular exposure. If the exposure is a regular or circular shape, it is also called as boss. So boss and stock are same thing. Those are the isolated exposure of batholith, but stock is more of an irregular shape. Boss is irregular shape. These are stocks you can say. These are exposed after erosion. Because of volcanic necks. So volcanic neck, or you can say that vent, sometimes that filled with magma. So magma can solidify in the vent. So that is called as a volcanic plug, or you can say lava neck. So when it solidifies, it will block the flow of lava. It is called as a volcanic plug. So after many years, it will expose to the surface like this. So these are very resistant to weathering. ମାନେ ବହୁତ କଣ weathering resistance ହେଇଥାନ୍ତି ହେଲା। ଆମେ ଦେଖା କି ଯୋଉ normally glacier case ରେ ଆମେ ପଢୁଥିଲେ crag and tail structure, it is also produced along that lava block because it has very high weathering resistance. When it comes to seal, so seal is a concordant bodies. Seal is a concordant bodies that produce parallel to the contour. So seal generally produced when magma is very, you can say the lava is very, sorry, magma is very viscous, hmm? less viscous, not very viscous. Seal produced when magma is less viscous. So magma can spread along the contour rock or along the bedding plane. So bedding plane along some spread କରନ୍ତି ଅଧିକ, right? So seal is a tabular sheet intrusion that has intruded between older layers of sedimentary rock beds or volcanic lava top along the direction of foliation meta rock. Any more of bedding plane or weak plane there more accommodate for it. It is a component intrusive seal body. Due to magma chamber जहाँ supply आता है, the supply by the magma chamber is less than the spreading rate. So it spreads at a greater rate than the supply. So that's why it is a flat sheet-like structure. म्हणजे पाणी पकाउँछु से easily spread गरिन्छ. So that means कि it has more sorry less viscosity. तुम्हें more viscous वाला पकेଇବା ताले से गोटे जगह ଟିକେ माउंट भला आगे प्रोड्यूस कर स्प्रेड करियो बट माउंट भला आगे प्रोड्यूस करियो बिकॉज़ कि it has less, it has less spreading rate. और डिपेंड करे कि तुम्हें को रेट रे सप्लाई करछो से अनुसार सेठी माउंट प्रोड्यूस ନାଇଁ ତୁମେ ଯଦି ବହୁତ ସ୍ଲୋ ସ୍ଲୋ କରୁଛ ତାହେଲେ ମାଉଣ୍ଟ ପ୍ରଡ୍ୟୁସ୍ ହେବାର ଚାନ୍ସେସ୍ କମ୍ ଅଛି। So laccolith, in case ତମର କଣ ହଉଛି laccoliths are produced when magma is viscous. It cannot spread like your seal will have spread well so that they will produce a dome seal with a flat base. Dome shape with flat base. that में bone shape ର କହିପାରିବ bone shape, dome shape है ना? So it is कौन acidic in nature. ସେଥିପାଇଁ ତମର upper layer ଗୁଡ଼ା uplift ହଉଛି because this acidic nature of the magma. So it will produce laccolith. Then Lopolith, they are also large igneous bodies, but Lopolith is always larger than Laccolith. No? Lopolith is not larger than Laccolith. So Lopolith is a basin shape structure like this. So the characteristic of Lopolith is it is layered. It is layered like this. That's why it is called LMI, layered mafic intrusion. So it is a basin shape or saucer shape and it is very larger than the laccolith. Then comes to Phacoliths. So Phacoliths are mostly found in orogenic belt because it is accumulated in the crest and trough of the fold. So crest and trough of the fold means we are talking about the tectonic disturbance. So it is produced in orogenic belt. It is accumulated in the crest and trough part because crest and trough part are the most weaker part. They are having fracture. तो लीव में फ्रैक्चर होता है फ्रैक्चर कोड था हमारा क्रेस्ट आउट रॉ रहता है तो जेहेतु magma they can easily accumulate it with the crest and trough of the fold. So it will generally lens shape ର ଥାନ୍ତି lens shape ର ଥାନ୍ତି. So these are called as phaccoliths. So Phacolith, Lopolith, Laccolith, Sills, all are your component bodies. So these are different structures. Another thing, your ring dike is a ring shape intrusion, and it produced when magmatic pressure is greater than lithostatic pressure is greater than magmatic pressure. So ring dike is a structure we will produce it as a circular outcrop. It is produced when lithostatic pressure is greater than magmatic pressure. Magma will surround that rock. Right? So this suppose कि मैं प्रेशराइज करूँ अधिक प्रेशर दूँ ताले से पर्टिकुलर रॉक को से ब्रेक न करके तार सराउंडिंग पार्ट रे से इंट्रूड बचे हो से रॉक को पुश करि पारे जोटा कि इन केस ऑफ उद्रवित कोन सीट केस रे रॉक टा डिफॉर्म करे दे रॉक टा डिफॉर्म करने ताकर वीकर जोन पार्ट रे से माने इंट्रूड कर दे सरफेस को नो लुक लाइक अ रिंग different shape of a intrusion radial dykes तुम कोई पर radiating jar तो so depend कर सब कहाँ पर depend कर structural control thing भी प्लस structurally जहाँ आसियो से अनुसार तो मैंने produce करता है different shape. So these are seal, you can say these are dykes. These are larger one is batholiths. Then these volcanic cones, they were extrusive, but these are intrusive. This comes to bismullite. So bismullite it originates from you can say laccolith. So laccolith is more viscous. So if any lava, it is more viscous than laccolith. It is more viscous than laccolith. If it is more viscous than the laccolith, it cannot spread. It cannot spread so that it will intrude or it will move upward to produce a shape like this, and it will produce a cylinder. It will produce like it will look like a cylinder. It will be cylindrical body and it will be a discordant one. It will be discordant one. So these are considered to be a conical or cylindrical laccoliths. Conical or cylindrical laccolith. So it is a modified laccolith in which the roof has been lifted in part by the peripheral faulting. So faulting will also help if there is a fracture, or another condition is also the viscosity condition. More viscous, like high viscosity. Okay. So this is called as a bismullite. So bismullite it is produced from the, you can say, laccolith structure, but it is discordant. So then comes to your superficial extrusive structure. Extrusive structure you will find that flawed basalt, where lava will pour out on a fissure, it will spread over the continent, the basaltic nature. Otherwise, you will find volcanic core, like your cinder, composite. Composite is consist of alternative tephra and lava flow. The cinder is also consist of only tephra pyroclastic material. So those can be considered as extrusive structure. So when magma flowing through the surface, the magma surface से flow करता है. So gradually the first thing will be crystallized, that is an anhydrous mineral. First कौन होगा? Anhydrous mineral crystallize करेगा. So anhydrous mineral जब crystallize करेगा, तो the amount of lava will decrease. So the rest of the lava, they will be saturated with volatile matter. So the rest of the lava कौन होगा? Volatile matter is saturated होगा start. So what a time is the saturation complete is the rest will just escape from the lava. They can produce lava tunnel, tube, or what we say, or you can say vesicles. So all of them have same process. Like the lava tube जो हम पूछते, that is similar to vesicle. Lava tunnel is when the upper portion of the lava solidifies faster than the lower portion or inside part of the lava. So inside part is still moving. So that is the lava tunnel. And ଯଦି lava flow ବେଳେ bubbles ଗୁରା ବାହାରୁଛି ଯୋଉଗୁରା, lava flow ରେ ବି bubble ବାହାରିବ, ସେଗୁରା escape କରିବ, ସେ ବି produce lava tube. So that is also similar to vesicles. So tube ଗୁରା କ'ଣ, vesicles ଗୁରା morely କି ଲମ୍ବା cylindrical form ରେ ନଥାନ୍ତି, normally irregular form ରେ ଟିକେ ଟିକେ ଥିବେ, but both ର mechanism ହଉଛି same. The vesicular magma produce हुए ଯେତେବେଳେ simple magma ରୁ ବା lava ରୁ ଯେତେବେଳେ volatile matter escapes. So the place of the volatile matter that remain empty, they produce empty space. छोट बड़ भल एग्जांपल होची चकुली देखियो, चकुली खाइला बेले पकेले तार कोणा काई हुए, काने जेति की वाटर थाए से जगह वाटर पूरा इवापोरेट कर जो, से जगह पूरा बेसिकली फांका रहे. Then these places, when these vesicular structure already formed, पूरा form ही सारी थी वो, so they will deposit. तो जेहेतु से vesicles अच्छी ओपन स्पेस अच्छी, obviously secondary mineral will accumulate, जोटा कि हमें कैल्सिडोनी, क्वार्ट्ज, कैल्साइट ये सब जिनसे सब तादर डिपॉजिट है कि सेटा को फिल करी, जोटा कि हमें कहते हैं ना amygdaloidal structure. तो vesicular structure होची, it is a formation of cavity, and amygdaloid it is the filling of the cavity. The vesicular structure is a primary one. Vesicular kana primary structure है, amygdaloid is a secondary structure. मतलब कि इतने infilling होची by secondary mineral, but it is also called as green earth mineral. वो कहते हैं green earth mineral. Means they are filling of the voids. So इसलिए तो कौन कहते हैं green earth mineral कहते हैं. Secondary देखो lava drain tunnel है ना. लाभा ट्रेन टनल होची उटा मोर लाभा ले सरफेस वाइज है तार आउटर पार्ट टा आगे एयर कंडक्टर आछो, सो सेटा आगे सॉलिडिफाई हे जिवो, बट इट इज स्टिल फ्लोइंग इन द इनर पार्ट, दैट इज कॉल्ड एज ट्यूब. मोस्टली इट इज प्रोड्यूस्ड बाय पावर हुए लाभा, जोटा कि हमें कोन रोपी लाभा, पावर हुए लाभा बा रोपी लाभा. So it is a simple mechanism, जो हमें क्षीर गरम कर फिर ऊपर सर पड़ जाए भीतर तले जाता है. ସେଇ ଟାଇପ୍ ର ଥିଙ୍ଗ କିନ୍ତୁ ଅପର ବାହାର ପୋର୍ସନଟା ଏୟାର କଣ୍ଟାକ୍ଟ ଜଲ୍ଦି ଆସେ ସିମିଲାର ମେକାନିଜିମ୍ ତୁମେ ପାଇପାଉଛି କୋଉଠି ବିଲୋ ଲାଭା କଣ୍ଡିସନରେ ବି ହେଲା ତ ବ୍ଲକ୍ ଲାଭା ବା ତାକୁ କଣ କହନ୍ତି ଏ ଲାଭା ତ ଏଇଟା ପ୍ରଡ୍ୟୁସ୍ ଯେତେବେଳେ ତୁମର ଏସିଡିକ୍ ନେଚର ଥାଏ ଭୋଲ୍କାନର ସୋ ଲାଭା ଫ୍ଲୋ ଯଦି ଏସିଡିକ୍ ଥାଏ ତାହେଲେ ସେମାନେ ଅଧିକ ବାଟ ମୁଭ୍ କରିପାରନ୍ତିନି ସୋ ନିୟର ଦ ଭେଣ୍ଟ ହିଁ ସଲିଡିଫାଇ ହୁଅନ୍ତି because of their high viscosity and ସେମାନେ ରଫ୍ ସର୍ଫେସ୍ ଗୋଟେ କ୍ରିଏଟ୍ କରନ୍ତି ନିୟର ଦ କୋର୍ ତାକୁ ବ୍ଲକ୍ ଲାଭା କୁହାଯାଏ ଯଦି ସେଇଟା ତୁମର ଲେସ୍ ଭିସ୍କସ୍ वाला magma ହେଇଥିବ ତାହେଲେ they will produce a smooth surface like ropy surface କୁହନ୍ତି surface ଟା wrinkle ଭଳିଆ ଦେଖାଯାଉଥିବ ଉପରେ ହେଲା ଯୋଉଟା କି you can see like this ହେଲା ଯୋଉଟା କି ବେସିକ୍ କମ୍ପୋଜିସନ୍ ଥିବ ଲାଭାଟା କି लो viscosity ତା ହେଲା ଏଇ ଯୋଉ appearance ରା ଅଛି exactly look like କଣ rope so ସେଥିପାଇଁ ୟାକୁ ropy lava କୁହାଯାଏ ତାର other name ହେଉଛି ପାହା lava so ପାହା ହେଉଛି କି it is the second most abundant lava and ଏଇଟା ମନେ ରଖିଥିବ କି convex to the flow direction तो এটা তোমার ফ্লো ডাইরেকশন আড়କୁ এগুলা কোন थे कन्वेक्स थे तो रोपी लावा रे तुम যদি কোন জায়গায় रोपी लावा দেখুছ তো you can see the direction of flow by saying the curvature of the rope तो रोपी लावा ର curvature ଟା सबरे पड़ता है कन्वेक्स साइडଥାଏ और कन्वेक्स साइड ଟା इंडिकेट करे फ्लो डायरेक्शन so this is your रोपी लावा and ब्लॉकी लावा next comes to tomorrow pillow lava so pillow lava is the kind of subopose tomorrow intrusion under you can say waterlogged condition जो जगह में तुम्हारा वाटर अवेलेबिलिटी अच्छी से जगह में तुम्हारा होते बेसिकली हम कहयो अंडर मराइन कंडीशन नॉर्दर्न स्वाम्पी कंडीशन जो भी स्वाम्पी रीजन अच्छी सेटिंग यही करियो it is की pillow shape or you can say spherical shape lava that is produced in the waterlogged condition or under marine condition you take one by one they will pile up upon one another so they look like a pillow so that's why called as pillow lava so it is same mechanism as more lava tunnel तुम कहते हो कि upper part बाहर part जो touches it easy they will in contact with the water so no easily cooling way so the part still expand करता है so it will produce a kind of bubble or you can say bulbous type of structure then again from that bulbous this bulbous will again it will break eventually and another bubble will produce over it like that they will produce a pillow type of structure as it is produced in marine condition mostly these are sodium rich structure composition sodium rich composition because they will normally exchange material with the magma chamber तो सोडियम लावा टा कौन है सोडियम रिच है कहना जो ओशन वाटर था ओशन वाटर सहित आयन एक्सचेंज है magma टा सोडियम रिच है ताको हम कहते the composition is here it is called as your Na rich magma so you can say albite rich मतलब spilite spilite so in between this pillow structure you will find fine glassy debris so हम कहते hyloclasite that produced by fragmentation of the hot lava so that hyloclasite commonly it quickly cools quickly crystallizes and produce a orangish brown metal that is called as palagonite so produce करा कौन palagonite ये जो आंका मझिया मझी जो रीजन अच्छी ये सब जगह है तो भांगी जाए किसी पार्ट से सब प्रोड्यूस कराती ଗୋଟେ structure that is called as palagonite When it comes to different joint structure produced way, like a seat of lattice structure produced way, seat of produced with key because of you can say removal of overburden. The overburden removal से तो seat structure produced way, है. Lattice structure तुम्हारा lava flow जो produce है पहले multiple layers of lava flow it is also can be considered as a foliated structure, like a lattice structure है. Columnar basically flawed basalt जो हुए जो की cooling and contraction जो produce हुए. So the cooling and contraction पे we produce तुम्हारा hexagonal जोड़ा कि हमें columnar basalt है ना hexagonal shape रा basalt produce करा. So this is your different joint structures. In columnar basalt, you will find a structure like this. Okay, this is a columnar basalt. You will also find marking like this. Horizontally, you will find marking on the columnar basalt. These are called as chisel mark. This is found in basalt, columnar basalt. It is produced from produced due to cooling to a common center. Yeah. So the joints are produced like this. These are the joint planes. These transverse band, these are called as your chisel mark. See, these are all having got transverse band.